7.4 goes over basic trig equations. If we look at the first page within our notes, it just goes over what a trig equation is with all of these equations that you have. For the first one, you have sine squared theta plus cosine squared theta is equal to 1. This is the same exact thing as saying y squared plus x squared is equal to 1. For that 2 sine theta minus 1 is equal to 0, you can actually solve that equation for sine theta. By doing that, you would just add the 1 to both sides. You get 2 sine theta is equal to 1. Then you would divide each side by the 2, and you would have sine theta is equal to 1/2. Sine, remember, is your y value. So this is the same exact thing as also saying y is equal to 1/2. So in order to solve this, you would actually use a unit circle and find wherever your y value is 1/2, positive 1/2. And the radian for that goes with that y value of 1/2 would be your answer. For the third equation here, you have tangent to theta minus 1 is equal to 0. For this one, yes, you could move that 1 over by adding it to both sides, but you would be left with tangent to theta is equal to 1. Dividing this by 2 is not possible because it's not 2 times tangent theta, it's tangent to theta. So it's two different things. So that one you wouldn't really be able to do anything with. If we look at some examples here, the first example we're going to look at is to solve the equation for sine theta is equal to 1/2. Remember, sine is y, cosine is x, tangent is y divided by x. Okay, so remember they're reciprocals also. For this one, we're dealing with the sine theta is equal to 1/2. We said sine is the same thing as y. So this is y is equal to 1/2. Find, using your unit circle, wherever y is equal to positive 1/2. You have positive 1/2 as a y value here, as well as here. Any other 1/2 that you see for your y values is a negative, so you don't work with those. You're going to take the theta or the radian that goes with that ordered pair where y is positive 1/2. So with this, we are working with pi over 6 as well as 5 pi over 6. So those are our two answers for this one. For our next example, we're solving the equation tangent theta is equal to 2. We said that tangent is y divided by x. If tangent is y divided by x, we're finding where y divided by x is equal to 2. Now, if you look at your unit circle, if we do y divided by x, it's the same thing as y times the reciprocal of x. If we start with that pi over 6, we would have 1/2 times 2 over the square root of 3. Those 2's cancel to be 1's, and you would just be left with 1 over the square root of 3, which is the square root of 3 over 3 simplified. For the pi over 4, you have the square root of 2 over 2 divided by the square root of 2 over 2, so we multiply by 2 over the square root of 2. These all become 1's to cross simplify, and that would just be 1. For the pi over 3, it would be the square root of 3 over 2 times 2 over 1. These 2's cancel out to become 1's, and it's just giving you the square root of 3. So doing that kind of helps look at this in a better way. We're looking for when y divided by x is 2. Are any of those 2? No, that's not possible. So this would just be no solution. For example 3 that we have here, it's really example 5. We're finding all the solutions for each of these equations. For example A, we have 2 sine theta minus 1 is equal to 0. So we're first going to take this 2 sine theta minus 1 is equal to 0 and solve it for sine theta. So first thing, undo that addition or subtraction. We're going to add 1 to both sides to get 2 sine theta is equal to 1. Then we divide each side by the 2. We get that sine theta is equal to 1/2. So again, look at your unit circle. Where is y? 1/2. This is the same exact thing as we did in the first example. So where y is 1/2, we have that pi over 6 and that 5 pi over 6. So both of these are your answers. For example B, we have tangent squared theta minus 3 is equal to 0. For this one, we're going to add 3 to both sides. We get tangent squared theta, tangent squared theta is equal to 3. From here, you want tangent theta, not tangent squared theta. So take the square root of both sides. Remember, when you're taking the square root of both sides in your equation, you got to include that plus or minus the square root of 3. When we did the division of y divided by x with that unit circle that we had before this slide, we said that that pi over 6, so that 30 degrees is the square root of 3 over 2, comma 1/2. If we did 1/2 divided by the square root of 3 over 2, we got the square root of 3 over 3. The pi over 4 gave us a 1 when we divided the 2, and then that pi over 3 gave us the square root of 3 when we divided both the y by the x. So if you look here, that 1/2 comma square root 3 over 2 is giving you that square root of 3. That's what we're looking for. So that one we're going to use. Your other square root 3's within this unit circle, you're going to look for the same ordered pair with opposite signs here. So 1/2 square root 3 over 2 is what you want to look at. That negative 1/2 square root 3 over 2 for 2 pi over 3 is going to give us that square root 3, that negative square root 3. So we will use that 2 pi over 3. Then the negative 1/2 negative square root 3 over 2 gives us the square root of 3 when we divide them. So we'll use the 4 pi over 3, as well as that 1/2 negative square root 3 over 2 gives us a negative square root 3 when we divide them. So we will use the 5 pi over 3. So all 4 of these radians are our answers. So we have pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. For our next example, we're solving the equation 2 cosine squared theta minus 7 cosine theta plus 3 is equal to 0. Cosine is x. So think of this as 2x squared minus 7x plus 3 is equal to 0. Solve this by factoring. You have an a other than 1, so multiply the 2 by the 3, it gives you positive 6. The factors of positive 6 that add up to be negative 7 are negative 1 and negative 6. So this factors out to be 2x squared minus x minus 6x plus 3 is equal to 0. Now that you have 4 terms, factor by grouping. You're going to factor out an x from the first set of parentheses and a negative 3 from the second set of parentheses. So this gives us x times 2x minus 1 minus 3 times 2x minus 1 is equal to 0. When we separate this, we're going to have x minus 3 times 2x minus 1 is equal to 0. Set both of these equal to 0 and solve. So x minus 3 is equal to 0, as well as 2x minus 1 is equal to 0. From here, move your 3 over. You get that x is equal to 3. Move the 1 over, add it to both sides, you get that 2x is equal to 1. Then divide each side by the 2, you get that x is equal to 1/2. Remember, You're looking at your unit circle and you're finding where x is equal to 3 and x is equal to 1/2. You cannot see that you have an x that is equal to 3 here. No x is equal to 3. So this part is impossible. It's not going to happen. However, you have x values that are 1/2, positive 1/2. That happens at the square root, or sorry, that pi over 3, as well as that 5 pi over 3. So pi over 3, as well as 5 pi over 3 are our two solutions for this problem. For your last example within this lesson, we have 5 sine theta cosine theta plus 4 cosine theta is equal to 0. If it helps to rewrite this as sine is equal to y, cosine is equal to x, this is going to give us 5y x plus 4x is equal to 0. Solve by factoring. Your both terms have an x attached to them. So factor out an x. It's going to be x times 5y plus 4 is equal to 0. So this is going to separate to be x is equal to 0 and 5y plus 4 is equal to 0. Your x is equal to 0. You can't do anything with that, so leave it alone. That 5y plus 4 is equal to 0. Subtract the 4 from each side. You get 5y is equal to negative 4. Then divide each side by the 5. You have that y is equal to negative 4/5. If you look at your unit circle and you check to see where your y or your x is equal to 0 and your y is equal to negative 4/5, you'll realize that none of your y values are equal to that negative 4/5. However, you do have x values that are equal to 0 at pi over 2 and at 3 pi over 2. So pi over 2 and 3 pi over 2 are our two answers here.